Hello, lab experts. Welcome once again to the RoK Diagnostics Podcast. In today's episode, we sit down with a medical laboratory scientist who has had time to specialize in molecular diagnostics, and our topic is going to be molecular diagnostics where next after COVID. We know that when we had issues a couple years ago with COVID, there was a large influx of money, of funding that came into the field. There was a large increase in the amount of molecular diagnostics done on the African continent and in Nigeria. But what happens now? Is the funding going to dwindle? Is it going to increase? What can we do to ensure that our continent and our various countries remain at the forefront of molecular diagnostics? So today we are here with Elijah Onyimi. How are you today, Elijah?
I'm fine. I'm great. Thank you for having me here. I'm really pleased the platform was set up and given the opportunity to talk about molecular diagnostics.
Thanks a lot for taking the time. We need more people to talk about molecular diagnostics because I think it's a tool that is essential in our countries, especially with all the infectious diseases that we suffer from. And it simplifies also testing in a sense because we haven't had necessarily all the tools that we need to do all the infectious diagnosis testing, but with the aid of some of these molecular tools, we can do a lot more. But before we get into that, tell us a little bit more about yourself. Who is Elijah?
So, Elijah is Elijah, basically. Elijah is a medical lab scientist. I studied from the University of Benin. When I came in, we were actually the first set of medical laboratory scientists they took in. So I didn't know about the course while choosing what course to study in the university. So the department just came up and then they just took us there. So I was like, what is medical lab science about? So I had to discover what it is while studying.
Yeah.
So obviously that didn't start with a lot of enthusiasm. But when I started to learn about molecular diagnostics, I remember they started teaching us about DNA, RNA, and then I was really interested in the course. It was biotechnology at the time. And then my interest was sparked up a bit, but there was nowhere to express it, so it just fizzled around there. But after schooling, we did an internship, which is a compulsory 1-year internship. And at the place we were doing our internship, they used to bring in patients and samples for Lassa fever diagnosis. And as a scientist, I knew at the time in Nigeria there wasn't any lab that was doing it apart from that lab. We tried to get into the place to train there, but we couldn't get into the place to train there. It was a sacred place. You only see people wearing nice lab coats, going into the place, coming out, So I was like, what is going on there? So after then, we did National Youth Service compulsory 1-year service. During youth service, I had the time. I did a lot of personal study with my time on molecular. I had a background understanding of what it takes, what goes on there. Started looking for a job, and I didn't get any job. So while waiting, I was just practicing working as a normal lab scientist somewhere. I got an offer to be a trainee molecular scientist. So that's how the journey basically started. And the person that trained me schooled in the UK, did his master's and PhD there. So when I came in, he trained me, gave me slides, books to read on it. And even though I had an understanding of it, sorry, you said brief introduction, but this seems like it's becoming a long introduction. But let me just paraphrase or shorten it. So I basically worked with him as a trainee, hands-on, and not just the head knowledge. I became hands-on, understood the basics, and then I got the opportunity to study molecular diagnostics master program in the University of Lagos. So that's how I went to do my master's. After doing my master's, the moment I got through with it, COVID came up. We went straight into the field, worked with some government, private institutions to set up labs that could do COVID diagnosis. And that's how they've set up a number of labs now and gotten accreditation approval for them. So that's basically me in a nutshell, professionally.
All right. And you said that already from the beginning you were interested when you had your courses at the university, when they started talking about DNA and RNA. What interested you about that? Because one thing I realized is that most students that I've gotten in the past, the basic idea of it is something like, oh yeah, they find it cool, but they aren't really interested in going into the details. So in your case, what is it that interested you?
What interested me was this. I looked at my environment I'm the kind of person I like to be inspired all the time. So I looked at my environment. I saw, like I said, remember I didn't know about this course. I didn't fill it in my form, but the new department was set up and it just moved us there. So I started asking, what is medical lab science about? So in my environment, of course, there are medical labs. So I went to a number of medical labs. I saw what they did or what they do. I didn't really like it. I went on Google. I saw what people did and I liked it because it's Google. Great images, great write-up. So when the time came and we're being taught DNA, RNA, and they were taught that each organism has its own unique DNA and unique RNA makeup. We already had the basic understanding that that can be a very good diagnostic tool to identify what organism is at play or what issue is at play. Initially I just became interested because it was different.
Yeah.
For me, it's different from the status quo in my own environment. It's something that can be brought to my own environment. I am interested. I want to create a new pathway, a new way of doing things. Because what I saw in my environment wasn't too palatable or comfortable for me. So for me, it was new interest, diversify, broaden the scope. That's what piqued my interest.
And how did you get ready? Because usually we say, I don't remember exactly the quotes, but that luck comes to those who are prepared or something of that nature. So how did you prepare? Because I guess when COVID came around, it boosted things, but you needed to have some kind of background behind. So yes, you did work with. So to be able to go and work with your mentor and all that, what is some of the work that you had to do in the background to sort of interest those people into helping you, into showing you some of the basics, some of the ropes?
So, life is a journey, and there are several things that add up, to get you to where you currently are. Firstly, I would say God helped me. Yes, God helped me. But He helped me by giving me energy and strength to do certain things I normally wouldn't do. So when I first had the interest DNA RNA, of course, we were in school and there was no way to practice it. So I just did my normal studies. But after school and then internship period came, I saw what was going on. I tried and I pushed my superiors. Let's go and do practice at that Lassa Fever research lab. We pushed and pushed because I was a microbiology major and we should be doing that as part of our rotations, but I wasn't able to do that. I wasn't able to get a breakthrough to do that. So I just felt like I had to know this. I had to do this. So the next free time I had, because usually in internship, we work 2-4-7. You even work at night. So there wasn't much time to settle down and do this study in-depthly. So after it, I got to do my youth service, so I had enough time. So I did studies, I paid for courses online, read books, followed the videos. I had time. So that was when I really grounded myself in the mentality of a molecular scientist. But after then, I had no job. So I applied to a molecular science lab. I applied to work for free at a normal lab. I just applied everywhere. At that time, the job that I said I got, it was one of the places I had applied to work even for free, but they did not take me at the time. But when an opening came, they then enlisted me as one of the people to go for the interviews. So the boss at the time chose someone and then chose me to be his own personal mentee, yes. So that's how the journey started. So having all the knowledge I had, there was no way to use my hands to do it. But when I got to the place, I was able to see the machines, see the processes, understand the better way of doing it, because you might have a procedure on paper. When you get to the field, you might not have all the materials, you have to improvise. So that's how I basically learned. It was from that time of working in that lab. Meanwhile, before getting to work in the lab, I had already applied for the master program. So that lab became like a booster to my molecular knowledge. And after getting that, I just continued with the master's program. So even during the master's program, I was still reading, still going to labs, So when I came out, I was basically ready.
And I think actually you said something that I think most people or most students don't do. You said you actually paid for some courses in order to learn, like separate from what you already did.
Yeah.
I think that's the kind of thing that helps. But many students today, they aren't necessarily willing to do that. I mean, it's not even just about paying courses, it's about being willing to go to find a lab and then be willing to go and intern there for free. Many students are not willing to do that, but that's usually a good way of getting your foot in the door and getting into some place that where they are doing interesting things. Because when you don't have any experience and everybody is asking you for experience, the best way to get in is to go and tell them, okay, I'm for free. You
How
can
do you
have me
come
for
up?
free. And then that's how you can then go and then impress them.
But at the time, I wasn't willing to just get in the door, though. I actually wanted to learn it, because for me, even now as I am now, there are things I want to learn now, but because of my schedule, I don't have a time to do a concentrated learning, so I have to space it over a few days or hours.
So now into the meat of the subject, molecular diagnostics and where next after COVID. First of all, how did COVID affect molecular diagnostics where you are? Was there any big effects?
COVID was the game changer. COVID, because like I said, when I say I was interested, some people, you look at it now and you say, oh, I see why you were interested. There's money there. At the time, there wasn't money there.
There was no money.
At that time, two labs, I remember, because I grew up in Edo State in Nigeria, there was only one molecular lab, and that was this particular lab that I'd written to. In Nigeria then, most of the labs doing molecular were doing it either for agricultural purposes, or most of them were for agricultural purposes anyway, plant breeding, crossbreeding, and all that stuff. And there wasn't labs totally focused on private research. Most of them were government-owned labs, and there were not many, So it was just an issue of interest, not an issue of, say, I'm looking for money or like that, But concerning how COVID brought a lot of money into the molecular space, a lot of money, because people, of course, who were afraid, panic was in the environment. How do we diagnose? How do I know I have COVID right now? And the only approved way that was very accurate, as recommended by the WHO and the government, was through PCR testing. So a lot of private individuals saw business in it, and so they pumped money, bought machines, bought the space, set up the lab, and of course it transpired onto traveling purposes too. If you want to travel, you must have a COVID result. So it went on to traveling purposes. The business was continuing, variant after variant, So even those that were hesitant at first, thinking, okay, this will just go away, saw that after some months, a year, it's still on, So everybody went fully into the business, and it opened up. Every state in Nigeria right now has a molecular lab, and has more than one molecular lab. And that in itself is like a miracle. It's a very big miracle. But it also creates a problem, because now that COVID is on the way out, a lot of labs are having to shut down or sell equipment. So that's the dilemma that's presented before us.
Yeah. So that goes to my next question. There was a rapid rise during COVID, but after that rise, now how do we maintain or keep increasing, even if it's slower? What do you think are some of the things that need to be done?
So there's something I learned while working, and also learned in my short time of practice, that nobody can do molecular diagnostics alone. There has to be collaboration. There are a lot of organisms, a lot of kits, a lot of primers, a lot of things that you cannot do alone. So there has to be a new policy of collaboration. And because of what COVID has done, there are a lot of molecular labs. We can literally coordinate the various labs that do this PCR testing from various regions and say, let's move beyond COVID. What are the infectious diseases in your area? Can we type them? Can we sequence them? We don't have a lot of sequencing lab, but now we have a lot of PCR labs. You can basically extract your nucleic acid, amplify them with your PCR, and send them to the sequencing lab to sequence. There's a lot of coordination that's needed to fully understand the kind of biological knowledge that's in our environment. Biorepositories are needed in these times, because a lot of organisms are, I don't want to use the normal word because I don't know what kind of audience we have. The normal word I will use is shape-shifting, even though the scientific word is mutating. A lot of organisms are mutating, becoming antibiotic resistant, and a lot of things are going on in the kingdom of even the microorganisms we have that we don't yet understand. A lot of times we are late to the party. It's when they're already
Yeah.
resistant, when they're already developing something that we then say, oh, how can we solve this? We can actually be ahead of the circle by understanding how these organisms are evolving, and this can be done through coordination. There are organisms, there are areas in my country, for instance, you have a Lassa fever burden. Other places you have monkeypox. Monkeypox is like a global phenomenon right now. It started
Mm-hmm.
from somewhere, so these are various ways that we can expand molecular diagnosis and make it still useful and a force to be reckoned with even in this present time.
Yeah. Yeah, I see why the push for collaboration will be interesting because when we had the problems with COVID, I was surprised. Well, I don't know how it was in Nigeria, but for example, here in Benin Republic, the silence was deafening coming from biologists and medical laboratory scientists. Because the way I was seeing it was we were the ones who were supposed to be talking about this, saying what is happening, what direction we're supposed to go. And then somehow when you talk to people, every time they were always trying to refer back to like the WHO, to like the government. But then the thing is, we went to school to do
Yeah,
this. I mean, we
yeah,
spent I don't know how many years in order to learn this. So how can we get to this stage and then start relinquishing the responsibility and then saying that it's other people who are going to tell us what to do when we didn't necessarily have all the molecular tools, but at least we had some basic tools to start work and then build from there. But somehow it seems like people in the field were as scared as the general population, where we're supposed to be
exactly.
the ones to be guiding the general population.
Yeah, exactly. And that's what I mean, really. We were behind.
Yeah,
We weren't in front, we were behind. We're acting like normal citizens instead of acting like scientists, rendering knowledge and saying this is what's going on, this is what you should think, this is what you should do. Everybody was guessing. At the time, initial information was it can be transmitted by air. Another information was, oh, it cannot be transmitted by air. Okay, you can transmit it by touch. You touch a place, even after 2 hours, 3 hours, the organism can still be alive. A lot of misinformation took up the space, a lot of agendas. And that was because scientists didn't take the lead. This is not the first time a coronavirus is coming up.
yeah,
It's not the first time that there's been. Oh, I just got out of power. Can you see me?
yeah, I can see you.
Okay.
Yeah, that's good.
The point I'm trying to make is that we were second guessing a lot of things because we had not done our research
Yeah,
to find out what's going on. And the thing is, when it came out, although China had a bit of a role to play in that aspect, but when it came out, they kept a lot of knowledge to themselves. They didn't release it, even to the US or to the public. So a lot of issues. But even at that, if we had good surveillance, we could have easily detected it from our place.
yeah,
Because we have easily
true.
stopped it right at the airport. But these are all various things that went on with our public health policies that caused the disease to spread so fast, so vast, you
Mhm.
know. Yeah.
Speaking of public health policy, do you think, and linking it a bit back to collaboration, do you think what we should do is more count on the private side to help with this collaboration aspect, or should we try and see how to work with government, or is it both, or which way should we lean a little bit more?
It is always both. It is always both. But the thing is, the policy movement usually will start from the public government or the public space because the government is the one that will bring about a policy. Then the people follow through with their policy um, alignment and the activities they do in alignment with the policy that the government brings forward. But the government
Mhm.
has to bring the policy forward. It's not a case of in private individuals making policy for the government. Even though there are certain instances, the business environment can sort of create a policy, but the incumbency of that is on the government to do. Private individuals, when they see an idea that's willing, they can be willing to follow an idea that's profitable to them. That's when private individuals usually commit themselves to such.
Yeah,
For instance, the government can say, let's do a policy now, a public health policy. We say our country, we have the northern region, southern region, east and west. We can have central labs in the north, central labs in the south, central labs in the east, central labs in the west. All other labs, what you do for us is you collect samples, you test people, when you observe a uniqueness of the characteristics of these presenting organisms or presenting symptoms, let's ship it all to the central lab. And then central labs can sequence, do more research on it, do cell analysis and all that on it, and we can come up with an idea of what's going on, But you don't have that in currently set up. And so you have a situation where things just pop up out of nowhere and it's already a problem. And the thing is, how do we solve this problem? So those are the things. If, for instance, some people are having malaria today, as simple as malaria is, and you're finding out that the usual drug that's able to treat them is not now able to treat them as effectively, why not do a research? Sequence the parasite genome. What's going on? What's different here? How are they handling these resistances? Release a research paper, make a publication, and then say pharmaceutical industries, look at what's going on. Resistances are being formed to the compounds that you're producing. Can we have new compounds? Does that seem so out of place to do?
I guess sometimes we are a bit late to the party, but the problem is at some point we need to figure out ways to be in front of the line also.
Yeah, that's true.
Now for the labs. So what I was wondering about as you're hearing the ideas was, I don't know how the environment is like in Nigeria, but would it be possible, let's say for a private laboratory, some of the larger ones over there, to decide, say, to become a hub for testing, for molecular diagnostics, for some of the forms of molecular diagnostics that might help make them extra money, and then focus on that? So let's say the government is not yet ready.
I didn't get your question. Can you
Because
please come again?
I was saying, as you were giving the ideas, I was thinking about something. Like you talked about the government trying to set up like central laboratories in various parts of the country. Now, given that our governments usually tend to be a bit slow when it comes to innovation, how feasible would it be, let's say in Nigeria, for one of the larger labs to decide to set up a lab that's, of course, going to make them money, like choose some pathogens that people may want to do testing for, and then set themselves up as a central hub where samples could be sent to? Would that be a possibility?
Yeah, that's a possibility. That's a very strong possibility. The thing is, if you look at the industry, I use the word industry because it has to be an industrial thing. A private individual cannot just think, let me just open a lab to just test samples. He wants to make money. It's a private business. So if I'm testing samples, who will my services be for? And how will I get money for it? So this is where, like I said, the industry, my power just came back. So this is where I try to balance the books. I understand that it's not easy to do these things because money is involved. So this is where it is. This is where the pharmaceutical industry comes in. Everybody wants to be treated, right? If we go to the US, for instance, pharmaceutical industries put a lot of money into research. Sometimes they buy up private labs that are involved in specific researches, and they just buy them up and say, use your equipment, use your technology, investigate this disease for me, find out what chemicals, biomarkers that I can use to produce a drug, and I sell it to the public. That's all they're interested in. The pharmaceutical industry has to be like a leading industry in this aspect, Another thing too is sometimes private individuals in the US and developed nations, they start up their own research labs for research purposes. They are just interested in finding out. And then they know that as they're going somewhere, they will have offers to buy up the lab or whatever. Is a win-win for them, because if they discover something nice, they themselves can start up a company, based on that product, So it has to be an industry thinking, an industry mentality. You have to think like, I'm not just a bench scientist anymore. I have to think of the industry, And this is where we have to work collaboratively, because if the pharmaceutical industries that we have in our nation are actually based abroad, they will want to take research ideas and research opinions from abroad, not from within the nation. But if you have indigenous pharmaceutical companies, you can say, I've seen a disease in an environment that is causing a lot of problems. You are a private lab, you do diagnostic testing, but can you set up a research lab? I'll sponsor it, and you're going to have one or two scientists, one or two technicians that will work on this and get me a drug I can market. Whatever it takes, it can be 1 year, 2 years, 3 years. I give it 3 years, run this stuff, and then we can push out our product. Once we push out our product, I'm sure I can make my money back in a few months because this is a disease that's prevalent in my environment. But most
Yeah.
times we wait for foreign companies, foreign organizations to take up researches for issues that are affecting us directly. Think for instance, sickle cell that is prevalent among African populations. Do we have a cure for it? And even if we have a cure, who designed the cure? Where did it come from? So it shows on our own scientific laziness to not take up issues that are affecting us and waiting for money. Sometimes you don't need money really for these things. If you're thinking business wise, I can say currently, I'm using malaria now because right now in our environment, malaria is very prevalent, very prevalent. And if you use malaria, for instance, a lot of people are becoming resistant to malaria tablets. A lot of people are having to use injections for treatment rather than tablets. A simple research can be, why are they this person is positive, right? This is flu season, the weather is cold around here. So a lot of people are having malaria, typhoid and all that. Can we find out what's going on with this parasite? What species of parasite is causing this? What is the genetic alteration that we're experiencing? If we find that out, how can we work with the pharmaceutical industry and develop a treatment for this and sell it now? Because patients are losing hope on tablets because they feel after using the tablets, they are still not treated for it. Just being in touch with the environment, you can already get research ideas. And if we're not scientifically lazy, you can go into your lab if you have one and find it out. I can take a parasite from a blood sample, for instance. I know it's present in red blood cells. I get a blood sample that is very positive for malaria parasite. I dissociate the red blood cells from it, dissociate everything, leave my genetic elements from it. It will be total nucleic acid that I will extract, both for the genomic person, both for the human being and for the parasite itself. I get my nucleic acid, I begin to do work. I begin to do work on it. What is going on with this parasite? If I need a pure malaria parasite, I make it pure and then I sequence. After sequencing, I find out what is going on here. Compare it with the normal genomic sequence for malaria parasite I used to have. Find out the homologies and the differences, and then when you do that, you can say, oh, this region of this parasite has so and so variation. We are noticing this, noticing that. This is a method the parasite is using to evade our human immune system or evade even tablets or drugs we're using. And we can even do this on our own, present it to pharmaceutical companies and say, look at what's going on here. We notice this. Can you now pump more money into our research so we do more of things like this for you?
Yeah, I think that's a direction
an efficient person to do that.
Because that's the direction we need to go. But the question is, how do we motivate people to get there? Because when we take the lab as an example, like even something as basic as just collating results that are already present to use it, not even necessarily to publish research, but for the lab itself, for the development of a laboratory itself, it tends to be hard to convince lab scientists to do that. I think also partially because there is also a lot of work to do, but how do we get to that point?
This is a very good question. You have to start from somewhere, You have to start from somewhere. Someone has to take the lead on this and create and make it like a trend. And for us who are just maybe scientists working in the lab or students or people who are still learning on the job, it can be difficult because you can't just start it up on your own. But those of us who have gone up enough to say we now have a lab of our own, even if you're not doing research, you're doing normal public testing, making your money a little from it, you can set out 5% out of the profit you make or 10% every month, every year, and say, let's put this into research. I know I'm doing only basic testing for now, and I know where the world of genomics is going to. Let me set out some money. Let me do even the basic research I can do for now and make sure it's environment specific. That's the thing. It has to be environment specific.
Yeah.
what are the things going on in my environment that I can research on, present my idea to a bigger lab or a company, that can make use of this knowledge. When I do that, for instance, I begin to show myself useful to such a company or such a bigger lab. There will come a time where that bigger lab or even company will want to collaborate with me with their finances and say, let's do something big together. I've discovered that you are consistent in this area. You're always coming up with researches on how to for us to improve our product. For instance, patients coming in to even if you have a little place doing your own diagnostics, patients will come in and sometimes they will tell you their symptoms. They won't tell you a particular test they want to do. They'll tell you the symptoms. And just by telling you their symptoms, you can already deduce the kind of things that may have happened to create that. It can be someone having a skin infection because they just told you, I just changed the soap I used last week. I started using a new soap. I started noticing this. As simple as that. That soap that the person was using, the person can give you the name. You can go and do a simple research on that soap and tell the manufacturer of the soap. That's just one case scenario. Someone can say, I started coughing yesterday after drinking so and so. You can do your research and find out, it has to be environment specific. Once it's environment specific, you can move on from there and create value for your research. Because that's what the problem is. It's when people see value from research, they can bring out their money to pay for it. And nobody sees the value in something that doesn't affect them.
Yeah, and especially when it's environment specific, you also have the public wanting you to keep doing the work. And so you have a lot more support from people in your environment, which of course makes you also happier because you'll be able to see the effects of the research you're doing around you rather than just doing some research for something and then putting it in a paper and then you're not even sure that people are reading your article. But at least if it's something that affects your environment.
That's what most of us do here. That's what most of us do here. You go to school, you want to finish with your bachelor's degree, your master's degree, they tell you do a research, and the research you're thinking something big, something wide, something I'll publish. It's not about publishing, it's about the people that did researches those days and made discoveries. There were things affecting them, things they saw in their environment that propelled them to say, let's find out what's going on here. And that's how companies like Pfizer, like big pharmaceutical companies came up. They didn't come up because they just wanted to do research and put on a paper. They weren't interested in paper. They were interested in solving real life problems. And so we have to get back to that mentality of solving real life problems. In my own environment, what are the medical issues going on that I can resolve or I can work to create more knowledge about so that they can ease the burden on my own personal environment. Even looking at your own outside environment, you can observe certain things, certain behaviors of your animals, your plants that are around you that is becoming different. All these are all research ideas, and you might not have enough money to do them, but just coming forward with the idea and preferring it to somebody puts you in a space where you can actually one day or even at that same time get an opportunity to effect a change through a research. And that's how value is created and money flows in the direction of value.
Definitely. So do you have any last words for anyone watching this? So as far as molecular diagnostics and where next after COVID, what's the final word?
So my final word is, well, I have a lot of final words, but my final word is always go with your passion. Believe in the things that God has put in your heart and make sure you do them with everything that you have because you don't know what tomorrow brings. At the time I was following the things I was interested in, there was no COVID. There was little to no prospect that this thing I'm learning will come out good in this country, but COVID came up and I came out from obscurity to someone that can actually effect a change in his environment. Because that time a lot of things took place. I had to leave where I stayed, went to a place, set up a lab, While at the time a lot of people were indoors working remotely. I was outdoors. I was everywhere, So just do that. And number two, always look at your environment, but look beyond your environment at the same time. Envision something, run with a passion, and when you do that, things will just keep aligning for new doors and new opportunities. Like I said, remember I told you I'm already trying to learn something now, and it's about cell theory, genomic editing, and all that stuff, because I know that's a phase that's going to pop up real hard very soon because we've learned a lot of transcriptomics, genomics, a lot of omics, epigenetics, many things. And all the knowledge are going to culminate in how can you make a cell, a living cell, to behave a certain way and do a certain function. And we are just headed there, but we don't yet know it because there are a lot of things that would change in this world. Even life itself will be redefined.
So Elijah, thanks a lot for being here with us today. Thanks for during all these years for doing the job, for following your passion, and for envisioning a greater, I'd say, future for molecular diagnostics in Africa. Where would people be able to get in contact with you if they want to? Maybe social media, LinkedIn, Facebook.
Okay, I'm on LinkedIn. My name on LinkedIn is Onyimi Elijah, Onyimi, and Elijah. Because you have Elijah in the Bible. So that's my LinkedIn. You can find me on Facebook, but I'm hardly on Facebook.
Yeah.
My name there is Elijah Okechukwu. So those are the
All
two
right.
places you can find me.
Thanks a lot again for being here today, and hopefully we'll have you very soon again to talk a little bit more about molecular diagnostics.
Thank you very much. It was my pleasure.
Thank you. Bye-bye.
Thank you too.
Yeah.